Assalamualaikum and good day to everyone. My name is Nafika Binti Azlan from 4BNA. So today I will be present about my final year project, which the title is The Potential of Nanocellulose Filter Paper, Neolamarckia Cadamba, for the removal of dyes from textile effluents. For the abstract, cellulose nanofibers, CNF in particular, has drawn considerable attention to the developments made in nanotechnology because of its unique properties. In this study, Neolamarckia Cadamba was used as a raw material in the manufacture of nanocellulose filter paper for the removal of dyes from textile wastewater. Therefore, the goal of this study is to investigate the effectiveness of the filter paper made from renewable forest resource through cross-flow filtration system in terms of the dosage of ratio 60-40 and ratio 70-30. Reactive dyes were thought to be the most problematic chemical in textile effluents due to their high water solubility, stability, and persistence in nature. Normalized flux, color removal, water quality parameters, and membrane surface properties were used to analyze membrane fouling behavior. The results show that color removal was 91.21% and the water quality parameters achieved were within the allowed wastewater discharge limit. The turbidity removal was 99.66%. For the introduction, water is essential to human, plant, and animal survival. However, nowadays the elevation of industrial activities, uncontrolled usage of chemical in domestic areas, and urbanization process keeps happening, and it can lead to serious pollution. And because of that, it need to minimize the safe water resource throughout the world. There are so many of industrial activities that contribute to this pollution are called as dye chemicals such as food processing, textile, leather, dyeing, and cosmetics. According to Department of Environment Malaysia, DOE, it is note that the major source of textile industry wastewater pollution are concentrated in Peninsular Malaysia, with Johor State having the highest number of water pollution source, 28.6%, followed by Pulau Pinang, 28.2%, and Selangor, 15.6%. So for this study, I will use Neolamarckia Cadamba as a nanocellulose filter paper to remove the wastewater. Neolamarckia Cadamba is a member of the Neolamarckia tribe in the Rubiaceae family and is commonly known as Kelempayan or Larang in Malaysia. This research is to assess the removal of wastewater dyes from textile industry wastewater, to investigate the effect of the CNF filter paper, and to investigate the functional group present in CNFs. For the literature review, the expansion of globalization and industrialization are the main factors of environmental issues which have become debatable among the researchers throughout the world, especially in water pollution issues. Dyestuff industries are the major contributors to the increment of environmental pollution, which contain the largest group of organic compound contaminants. The textile dyes, along with a large number of industrial pollutants, are highly toxic and potentially carcinogenic. So they are related to environmental degradation and various diseases in animals and humans. Although dyes have been known to mankind since ancient times, it was not until the late 19th century that synthetic forms began to be manufactured along with intermediate compounds, causing a high incidence of bladder cancer, especially benzidine and 2-methylphenidate. For the methodology, first prepare the wastewater dye sample from textile industry, which located in Senai Johor, and then prepare the CNF filter paper. After that, doing the cross-flow filtration in various conditions, which are permeability test and normalized flux. After doing the cross-flow filtration, Need to compare the wastewater before and after the filtration process by doing the characterization of textile effluent, which are pH, color, TSS, stability, and COD. After finish the characterization of the wastewater effluent, need to do the characterization of CNF filter paper before and after doing cross-flow filtration system. The characterization of CNFs filter paper are tested by using Fourier transform infrared FTIR, and then can proceed to result analysis and discussion. For result and discussion, the result of wastewater characterization on parameter is shown in table 1. For chemical oxygen demand, COD, the initial COD reading is 379 mg per L, which means it indicates that there are more oxidizable material in the dye wastewater. If so, the water dissolved oxygen content will have decreased. It needs proper treatment before discharge into the water body to minimize pollution potential since the value is higher. For the final result of COD, which is after the filtration process, the value is 23 mg per L. The final COD show a low COD level compared to the initial. This means that the filtration process was managed to reduce the COD level. For the color removal, the initial ADMI of textile dye wastewater with optimum parameter tested, as in table 3, was 1706, while the final is 150. The color removal percentage obtained for the optimum was 91.21%. Based on the observation, the color of filtered effluents is essentially the same as the color of pure water, if not exactly the same. For the turbidity removal, as in table 5, the initial turbidity is 594 NTU, while the final is 2 NTU. This shows that before the filtration, the turbidity is high compared to after the filtration. The turbidity removal for this is 99.66%. This proves that the efficiency of CNFs filter paper produced from Neolamarckia Cadamba on turbidity removal was very excellent. Based on the legislation in Malaysia, the turbidity required was less than 10 NTU. By using the CNF filter paper, the turbidity of wastewater could be filtered effectively and ensured to be within the range limited by the government. To put in summary, by comparing the value of those parameters with the acceptable condition of discharge of industrial effluent or mixed effluent of standard A and standard B, they are all can be categorized under standard A because they are in range value in standard A. In conclusion, this study was successfully conducted as the dye wastewater removal process through filtration process using Neolamarckia Cadamba via cross-flow filtration system show positive performance. The characterization of the membrane before and after the filtration process support the ability of the membrane to remove dye wastewater and increase the water quality. The cross-flow filtration system help to enhance CNF filter paper, help to keep longer membrane life by preventing irreversible membrane fouling, and maintain a uniform flow rate of pyramid. According to the result, the dosage filter paper ratio 60-40 was chosen as the optimal dosage, and 100% concentration was chosen as the optimal concentration. 2 bar was chosen as the constant operating pressure because it is preferred by the industry in order to reduce running costs for the treatment. This study also managed to prove that Neolamarckia Cadamba has a high percentage of color removal and also turbidity removal. The final chemical oxygen demand (COD) reading also show a good result. Overall, it can be concluded that the study was able to contribute to the treatment of the textile industry for wastewater effluents. That's all from me. Thank you.